Welcome to this first lecture on astrophysics and cosmology. The picture over here shows you the sky, a part of the sky during daytime. As it is quite obvious, the only astronomical objects that you typically see in the sky during daytime are the sun and sometimes the moon. And on rare occasions where there are very bright comets in the sky, you can also possibly see them. So, astronomy is essentially a nocturnal subject, something which is studied when normal people all go to sleep. The astronomers then get down to work, like thieves and burglars, you may say. Okay. So, this picture shows you a part of the sky at night. The part of the sky that is shown over here is particularly important because you can see our galaxy, the Milky Way, in this picture. We shall come back to the Milky Way in a later lecture. For the purposes of the current lecture, of the present lecture, it suffices to note that every bright object that you see in this picture, nearly every bright object that you see in this picture is a star. So, what we see is that the night sky is dominated by stars. If you look at the night sky, which I am sure all of you have done, it is dominated by stars. Stars are predominantly what you will see. And the night sky, the stars in the night sky have fascinated the human mind. They have roused the human curiosity for few thousands of years, over few thousands of years. This is particularly so before the advent of electricity. With the advent of electricity, the night is largely illuminated in most of the inhabited areas, and in some places it is so bad that you cannot even see the stars at night. But before the advent of electricity, when it really became dark at night, people naturally spent a large part of possibly a part of their time looking at the sky, and the stars aroused the curiosity of many people over thousands of years. It was noted long ago that the stars maintain fixed positions on the sky over periods of few years. Okay, so, if you look at the sky, say over the period of a year or 2 years, you will see that the relative positions of the star with respect to one another remain fixed, they do not change. So, the position of the stars on the sky are fixed. The whole sky, this whole fixed position of stars. So, if you look at the sky say tonight, and if you happen to see this part of the sky, the part that is shown on the screen, and then again if you look at the sky at the same time tomorrow night, you will see exactly the same pattern. Okay. And the entire pattern that you see here, the entire pattern of fixed stars on the sky, it revolves around us. So, if you look at the sky say continuously for 1 or 2 hours, you will see that the entire pattern, the pattern remains fixed relative to one another, the stars remain fixed, but the entire pattern revolves around us, rotates, and it completes one whole rotation in 24 hours. This diurnal rotation, it is now known, arises because of the rotation of the earth. Okay, so, the earth is rotating, it has a period of 24 hours, and the sky, the fixed pattern of stars, appears to rotate because of the rotation of the earth. Okay. And the stars we also know now that the stars are at great distances from us. So, even if the stars move, their positions, their angular positions in the sky will not change significantly over time scales of few years, at least to the naked eye. So, the motions of the stars, even if they are there, will not be visible on the sky, because the stars are very far away. Okay? And it is as a consequence of this that the stars remain fixed relative to one another, and this fixed pattern of stars rotates. The fixed pattern is fixed, the pattern is fixed on the sky, and the entire sky rotates, seems to rotate around us. Okay. Now, ancient people, they looked at the pattern of stars on the sky and they identified certain distinct patterns in these, and these patterns that they identified, okay, are known as constellations. Before we go to that, let me show you what the night sky will look like if you go out tonight at around 8:30 or 9 and look at the sky. Okay, so this picture, it is a sky chart. It shows you the sky as you expect it. If it is clear tonight, if you go out at around 8:30 or 9, it shows you, this picture shows you the position of all the bright stars that you expect to see. Okay. So, this is a sky chart. It shows the upward direction is north, east is to the left, and west is to the right. And if you go out around 8:30 or 9, you expect to see something that looks like this. If you go out earlier, then you will not see these parts, they would have just risen, they would be not have risen then, and these parts would be shifted to the left. That is the rotation of the sky around us. Okay. And if you go later, then these stars would have shifted to the center and these would have shifted out. So, I suggest that you go out tonight at around 8:30 or 9 after dinner and have a look at the sky and see if you can, and compare it with this picture, okay, and see if you can identify these stars on the sky. Okay. Now, the ancient people, they looked at the sky and they identified fixed patterns, and these patterns which they identified, these patterns are called constellations. So, I have already discussed the first 2 points, the relative position of the stars are fixed and the whole pattern rotates around us. So, we are now discussing this third point, that the ancient people, they identified these patterns in the distribution of sky, of stars on the sky, and these are called constellations. And the constellations that were identified differ from place to place, culture to culture essentially, and these constellations that were identified are closely related to the mythology of the people. So, the constellations that were identified in, say, India and by the Red Indians in America, by the original inhabitants of the American continent, and by the Europeans or the Egyptians, they would be different, they could possibly be different, some of them may be same. And many of these constellations, the patterns, they are quite obvious, but not all of them. Some of them, they require someone to show you. Okay. So, somebody really imaginative must have identified that this looks like this. Okay. And different people, so the definition of the constellations also change with time, in the sense that what, say, people 1000 years ago defined as constellations, possibly 500 years ago people redefined them. And in 1929 the International Astronomical Union, the IAU, fixed the 88 official constellations. So, all the stars in the sky were divided into 88 official constellations. So, these are now officially accepted as defined by the International Astronomical Union. So, they have identified 88 constellations, the boundaries have been fixed, and every star now belongs to some constellation or the other. So, it covers the entire sky. okay, and there are 88 of them. So, if you wish you can look up the names of these constellations, they are available. So, this picture shows you the Orion constellation, and the Orion constellation, let me go back to this picture. The Orion constellation is visible over here, you expect to see it, it is very prominent in the sky. So, if you go out tonight, you cannot miss the Orion constellation. Let me explain to you what this Orion constellation, why it is called Orion, what it looks like. So, it essentially is a warrior, a hunter, okay, and this is the belt of the hunter. These 3 stars is the belt of the hunter, these are the legs. So, this is one leg, you can imagine the belt. So, it looks like this somewhat. There are 3 stars which make the belt, and then there is one star here and one star here, and then there are 3 stars here, which maybe you can think of something like this, and there is a sword which has 3 stars over here. So, this is the sword of the hunter, the hunter's sword. This is the belt, you can join this here, one leg, and this is the other leg, this is his one hand, and this is the other hand, and the head possibly here. Okay. So, this is a hunter, Orion the hunter, he is followed by a dog, we will not go into that. So, Orion is a very prominent constellation on the sky, and if you just go out tonight, you can see Orion around 8:30 or 9, it will be to the little to the east at that time, okay, and you can easily identify this. The Orion constellation is a very interesting constellation, and the belt, the sword, one of the stars in the sword has a nebula. There is a gaseous cloud around it, the Orion nebula, where star formation is taking place. But these are details which we shall not go into right now. I suggest that you go outside tonight and have a look at the Orion constellation. This is another constellation, the Ursa Major or the Big Bear. Okay. Now, the bear is not so obvious, but it is referred to as the Big Bear. In Indian mythology, this is referred to as the, in India this is referred to as the Saptarshi Mandal. Okay. So, this is the Ursa Major, and there is also the Ursa Minor, and this appears, let me again go back to the picture of the sky, this appears over here in these regions to the north, Ursa Major and Ursa Minor. And what is interesting is that this constellation essentially points to the pole star. So, this is the pole star Polaris. Okay. So, we have the pole star Polaris. And the pole star Polaris is very interesting because the rotation axis of the earth points towards the pole star. Okay. So, the pole star again is somewhere over here, that is the pole star Polaris, and the rotation axis of the earth shown over here points towards the pole star. So, as the earth rotates, all the stars they move on the sky, but the pole star it remains fixed. The pole star does not rotate as the earth rotates, because the earth's axis is aligned towards the pole star. Now, it is now known that the earth's axis of rotation is not fixed. That is a very interesting fact. So, the direction of the north pole is not fixed, and the rotation axis of the earth precesses. It precesses because of the tidal forces. So, we shall discuss tidal forces later. So, the rotation axis of the Earth's rotation axis precesses, it goes, it does not remain in a fixed direction, but it goes around like this, and it does one revolution in 26,000 years. The period is 26,000 years, and it does not remain fixed because of the tidal forces due to the sun and the moon. So, the sun and the moon exert tidal forces on the earth, and this causes the rotation axis of the earth to precess with a period of 26,000 years. So, at present the rotation axis of the earth points towards this pole star Polaris, but in the past it pointed in a different direction, and in the future again it is going to point towards some other star. Okay, so, it is something that is changing very slowly in time. Over our lifetimes, the change is really very small. It is there, but it is very small. So, we have discussed very briefly the fixed objects in the sky, the stars, and people have visually identified certain patterns called constellations. There is another point which I should mention before we go ahead. The point is that the constellations are not real. What do I mean by this? What I mean is that the stars that we see in a constellation, for example, the stars that we see in the Orion Nebula, all of these stars, the stars in the belt or the stars in the sword, they are not physically associated. So, that stars in the belt and all of this pattern of stars that you see, that you make out, these stars are not physically associated with one another. They are not located in the same place. They are actually located at different distances from us. Okay. So, it is like this, that I am an observer sitting here on earth, and there could be, what we see is the projection of everything onto the sky, and there could be one star over here and another star over here, and I will see them projected and they may appear nearby. Okay. So, this is, let us say, one star, another star, and maybe another star here. They are actually at quite different distances, but when I look at them on the sky, they may appear very close. Okay. So, the stars that make up the constellations are not physically associated, they are typically at different distances. It may happen that one or two of them may be physically close, but typically they are at different distances and they are in no way physically connected with one another. They just appear to be together, and the pattern just appears on the sky, that is all. So, if I go to some other star and see some other, say if I live in some other planet elsewhere in the universe, I will, in our own galaxy, I will see some totally different set of constellations. Okay. So, they are just things that we see on the earth, but still they have their utility. Okay. And they have the utility because they help you identify different parts of the sky, identify objects on the sky, etc. Okay, which is why IAU, the International Astronomical Union, has taken the pain of identifying 88 constellations. Okay. And we still refer to objects by the constellation in which they lie. For example, there is the Andromeda galaxy, which is the nearest full-fledged spiral galaxy. Okay. It is called the Andromeda galaxy because it lies in the Andromeda constellation. Okay. Now, in addition to these fixed stars whose relative position remain fixed in the sky, there are other astronomical objects which do not maintain fixed positions. These are the wanderers, okay, and the name planet comes from there. So, these objects that move around, wander on the sky, the sun, the moon and the planets, they are all seen to move on the sky relative to the fixed stars. Okay. They do not have fixed positions on the sky. So, this is one very distinctive feature that distinguishes between planets and stars. the stars maintain fixed relative positions. Over a period of a year, you will see it in the same relative configuration, whereas the planet over a period of a year would have moved. The sun and the moon, they all move on the sky, okay, in addition to the rotation of the sky. Another very distinguishing feature is that the bright planets, they do not twinkle, whereas the stars, they twinkle. Okay. The stars, they twinkle, whereas the bright planets do not twinkle. Okay. And the star, there is a third point which I shall which is mentioned just over here. So, these objects that wander, their wandering is not over the entire sky, their wandering is restricted to a narrow band on the sky called the zodiac. Okay. So, the wandering of these planets of the star and the moon is restricted to a very narrow band which is called the zodiac. And the sun goes around in a very definite orbit in the zodiac, that is, has a very definite path on the sky. It is called the ecliptic. Okay. And the zodiac is a region around the ecliptic. So, you will find the planets only in this region mainly, okay, only in this region, whereas the stars are distributed all over the sky. So, you will not find planets very far away from the ecliptic. So, let me explain this now a little bit more, but before going into that, there are these constellations that lie in the zodiac. So, there are 12 constellations that lie in the zodiac, and these 12 constellations play a very important role in another subject called astrology. Okay. So, astrology is based on these 12 zodiacs. So, these again are constellations. They have been shown over here. These are again are constellations. Okay. The zodiac, the signs of the zodiac, these are all different constellations, just like the 88 constellations that we have discussed, they are part of that. But these are the constellations that lie along the zodiac. So, the stars, the planets, the moon and the sun, the planets, moon and the sun, they move only amongst these constellations. They never go into the other constellations. Okay. And astrology is based on the position of the sun, the moon and the planets at the time of your birth, etc., etc. Okay. So, that is why astrologers are interested in the zodiac. So, these are the 12 constellations that lie along the zodiac, these are the zodiac symbols. Okay. So, let us now understand this whole thing, try to get some picture of what is going on. The earth, we know, revolves around the sun. So, it goes around the sun in an orbit like this, with the sun at the center, and the earth, we also know, rotates around an axis. Now, the rotation axis of the earth, which I just told you points at present towards Polaris, is not perpendicular to this plane of the orbit, but it makes an angle, the angle being 23.5 degrees roughly, 23.5 degrees. So, the rotation axis of the earth makes an angle of 23.5 degrees shown over here with respect to the normal to this orbit of the earth. So, the rotation axis makes an angle 23.5 degrees with respect to the normal to the orbit, plane of the orbit. This plane of the orbit is called the ecliptic plane, it is called the ecliptic plane. Okay. Now, when the north pole points towards the sun, we have summer in the northern hemisphere and winter in the southern hemisphere. Then the sun, then the earth goes into this position where both the north pole and the south pole are equally illuminated by the sun, and so we have summer, then we have autumn, and then it comes to this position where the north pole points away from the summer, and then we have autumn, and then here we have winter when the north pole points away from the sun, and the northern hemisphere is winter like at present, and the southern hemisphere points towards the sun. And then it comes here again, we have spring where both are equally illuminated, and then it comes back over here. So, there are these 4 positions which are particularly important. So, the sun, okay, so this is the winter, this is winter, this is spring, this is summer, and this is autumn. Now, we are interested in what this appears from the earth. Sitting on the earth, what does it appear like? Okay. That is what is of interest to us. Now, when we sit on the earth and look at the sky, it is convenient to define something called the celestial sphere. Okay. So, this is a sphere at infinite radius, and all the objects that we see on the sky we think of as being on this sphere called the celestial sphere. Okay. And the rotation axis of the earth, we extrapolate that. So, this is the rotation axis of the earth, we extrapolate that, and the place where it intersects this celestial sphere, this is the north celestial pole and this is the south celestial pole. Okay. Just like the north pole of the earth and the south pole of the earth, we also have the north celestial pole and the south celestial pole. And if you take the equator of the earth, which is the plane perpendicular to the rotation axis, and extend that, it will intersect the celestial sphere at the equatorial plane. So, that is the celestial equator. So, the blue curve over here is the celestial equator. It is the equator of the earth essentially, the perpendicular to the rotation axis. If you extend that to infinity, the place where it intersects the celestial sphere, that is the equatorial and the celestial equator. Okay. So, we have these celestial, we have the celestial equator and we have the north celestial pole and the south celestial pole, and the whole sky rotates around this, but we are not interested in that. The positions of the stars remain fixed on the celestial pole in the celestial sphere. So, we are not interested in the rotation of the sky. So, the position of all the stars, this is a sphere that is fixed to the stars. The stars maintain fixed relative positions. So, this sphere, the celestial sphere, is fixed to that. Now, when I look at the sun sitting over here, sitting on the earth, what will the position of the sun look like? To understand that, let us go back to the previous picture. During summer, the sun during summer, the sun is going to appear to the north. During summer, the sun is going to appear to the north. So, this corresponds to summer. During summer, the sun, you can see here, this is summer. The equator is perpendicular to the rotation axis. So, the equator actually points downwards now, and the sun appears to the north, it is fixed. Okay. So, in this picture, the sun during summer, the extreme north, the furthest position from the equator is the peak of summer. Okay. The peak of summer is the furthest position from the equator. It is called the summer solstice. Okay. So, that is the summer solstice. And then then after summer we have autumn. In autumn the sun is exactly perpendicular to the rotation axis. So, it is in the equatorial plane. So, the sun has moved down towards the equator, and at autumn it exactly in the middle of autumn it exactly intersects the equatorial plane, and then in winter the sun has moved to the southern hemisphere on the sky. Okay. So, now the south pole points towards the sun, the equator points upwards. So, the sun is now in the southern hemisphere. So, the sun has moved to the south, and this is the extreme, the furthest below the equator that the sun gets. This is the extreme of winter around 22nd December, and then the sun again moves up, the sun moves. So, the earth moves from here to here, and the sun appears to move towards the equator. And then we have the spring equinox in the middle of March, and so this is the spring equinox where the sun again cuts the equator, and then the whole thing repeats. So, the sun appears to move in an orbit like this, and the orbit of the sun on the sky, the apparent orbit of the sun on the sky, makes an angle of 23.5 degrees. Okay. So, in 1 year, over a period of 1 year, the sun completes that great circle, which makes an angle of 23.5 degrees with the equator. Okay. And this great circle that along which the sun moves, this great circle is called the ecliptic. Okay. That is the motion of the sun on the sky. So, the sun does not maintain a fixed position, its position changes, it changes over the period of 1 year, it goes along a great circle. So, it does a motion on the sky, and that is inclined at an angle of 23.5 degrees to the equator, the celestial equator, and this curve is called the ecliptic. Okay. And the plane through this is the ecliptic plane, and this position when the ecliptic, where the ecliptic cuts the equatorial plane, is the spring equinox around 22nd of March. Okay. And the day and the night are exactly equal on that date. After that we have summer, and then again we have the autumn equinox, and then we have the winter. So, we have summer and winter, we have solstice, the sun keeps on moving further up, and then it comes to a stop, solstice, and then again it goes down. Okay. And these have been identified few thousands of years ago. So, thousands of years ago people identified this the fact, the motion of the sun on the sky, and we have in India we have the Posh Makar Sankranti or Posh Sankranti. In Assam it is called Bihu, in Tamil Nadu they celebrate Pongal, in Punjab they have Lori. All over India it is celebrated, it is well known. Okay. So, all of these things have been known for over thousands of years by people all over the world, it is not something new. Okay. But the reason now we believe, we know, is because of the fact that the earth's rotation axis is tilted at an angle of 23.5 degrees. Okay. Now, let us take up the other. So, why do the moon and the planets all appear to move around the ecliptic? Okay. Now, it is now known that the moon revolves around the earth, okay, and the orbit of the moon is nearly coplanar with the earth sun orbit. Okay. So, the orbit of the moon is nearly coplanar, which is also why you have eclipses. If the orbit of the moon were perpendicular, then you would not have so many eclipses. Okay. So, the orbit of the moon is nearly coplanar with the orbit of the earth and the sun, and as a consequence the moon also appears to move around very close to this ecliptic. Okay. The moon also does not deviate very far away from the ecliptic. Similarly, except for Mercury, all the other planets also have orbits which are nearly coplanar within a few degrees. So, all the planets they move in orbits which are coplanar with this orbit of the sun and the earth of the earth around the sun. Okay. So, all the orbits of all the planets are nearly coplanar with the earth sun orbit, and they move a little bit off this plane. And so, as the sun moves along this ecliptic, the inner planets they move very close to the sun, they move along with the sun nearly, and the outer planets they all do not deviate very far away from this plane. Okay. And they cover the region called the zodiac, a band on the sky called the zodiac. So, all of these the wanderers they move around only in a small band around the ecliptic. Now, this spring equinox is extremely important, and at present the spring equinox points along Aries, along the constellation Aries. So, at present the spring equinox points along Aries. To be precise, in 2000, in the year 2000, it will point along the constellation. It has pointed along the constellation Aries. Okay.
So,
yeah.
So, in this, when you make the celestial sphere,
right.
So, where is the observer related to that sphere?
Right. That is the point which I did not mention very explicitly. Where is the observer? So, the observer, the celestial sphere is a sphere centered on the center of the earth. Okay. And since it is of infinite radius, the fact that we are not at the center of the earth, but at some distance from the center does not make matter. Okay. So, you can think of the celestial sphere as being centered around us. Okay. So, when you look at the sky, you are basically at the center of this celestial sphere, and the rotation does not, we are not bothered with the rotation of this sphere. It rotates every 24 hours, the whole thing goes around, we are not interested with that. Okay. So, all the stars maintain fixed positions in the sky, and the sphere is relative to one another, and this celestial sphere is fixed to that. So, the position of the fixed stars do not change on the celestial sphere. The position relative to that we see, what we see is going to change because it rotates every 24 hours. Okay.
So, for two observers, one observer in this hemisphere and some other observer in opposite direction.
Right. They will see different parts of the celestial sphere.
But
But the same, they are still at the center. So, the part of the celestial sphere that you can see will depend on which hemisphere you are located in. Okay. So, if you are located in the northern hemisphere, you will only see things above. Okay. So, if you are located in the northern hemisphere, your view will be restricted to the northern parts near the northern celestial pole. If you are in the southern, hemisphere, obviously you cannot be able to see the north pole or things near the north celestial sphere. So, people in the southern hemisphere will be seeing things near the southern celestial pole. People in the equator are privileged because they will see nearly the whole very large part of the celestial sphere. So, in India, for example, we are quite privileged in that way, we are close to the equator and we can see a large part of the celestial sphere. Okay. Now, we cannot see the whole of the southern celestial sphere, but we can still access a large part of it, okay, which is one advantage of having your observatory located near the equator. Okay. Fine. So, what I was telling you was that at present in the year 2000, the spring equinox, the location of the spring equinox was in the Aries constellation. But I also told you that the rotation axis of the earth precesses, and it precesses very slowly, but it does precess. Okay. So, as a consequence of this, the location of the spring equinox also changes with time. Okay. And in the year 2000 BC, the spring equinox was located in the Aquarius constellation. Okay. So, the spring equinox, the location of the spring equinox with respect to the other fixed stars has changed gradually over time, and this is something that has to be appreciated, because we use the location of the spring equinox. So, people have in different cultures, okay, people have used the location of the spring equinox to set their time scale. Okay. And so, the time scale is decided by the event that the sun enters, sun has we have the spring equinox. So, say we start our calendar from the day we have the spring equinox, okay, which is roughly what we do now also, right. Our calendar, the Bengali calendar particularly, starts from the day, roughly is decided by the day of the spring equinox, okay, but the spring equinox itself has changed over time, okay, because of the precession of the Earth's axis of rotation. And so, this is an important point to note. In 2000 BC, it was in the Aquarius constellation. So, it was when the sun entered the Aquarius constellation, and now it is when the sun enters the Aries constellation. So, this keeps on changing with time. Okay. So, finally, let me tell you about the celestial, the equatorial, the coordinate system that we use on the sky. This coordinate system is called, the one that is most commonly used is the equatorial coordinate system. So, this is a celestial coordinate system. It is a coordinate system that is fixed to the celestial sphere. Okay. And this coordinate system is very similar to the latitude and longitude that we use on the earth. It is very similar to that. It is also very similar to the spherical polar coordinates that we use in 3 dimensional geometry. Okay. So, so this is the celestial sphere, and the aim of the coordinate system of this equatorial coordinates is to label every point on the celestial sphere. The whole sky is on the celestial sphere. So, the aim of this coordinate system is to label every point on the celestial sphere, and the observer, that is us, we are located at the center. Now, so let us see how we label this point on the sky, this particular point on the sky. So, there is a point which is shown over here by this black line. So, we are looking in this direction, there is a star in this direction, let us say, and we want to give coordinates to this. Okay. So, what we do is we project, okay, one coordinate, there are 2 coordinates that are used. We all know that it requires 2 coordinates to define a point on a sphere. It is a 2-dimensional surface. So, there are 2 coordinates needed, and one of these coordinates is the angle that this point makes with the equatorial plane. So, if you measure this angle that it makes to the equatorial plane, you get one coordinate. This is very much like the latitude that we use on the Earth's surface. Okay. So, it is very similar to the latitude that we use on the Earth's surface. The equatorial plane corresponds to 0, and if you are looking at a star which is in the northern hemisphere, then you give it a positive angle. If it is below the equator, you give it a negative angle. This angle is called the declination. Okay. Declination, dec. So, the angle is called the declination. Dec. And it is the angle that, say, a star or a position on the sky, it makes with the equatorial plane. Okay. And this is measured in degrees, and if you want smaller units, each degree is divided into minutes, 60 minutes, and every minute is divided into second. So, these are arc seconds, okay, arc minute and arc seconds. Okay, so let me write it here, arc minute, and we have arc second. Okay. So, degrees, arc minute and arc second. So, if I give you a declination 2 degrees, 25 arc minutes, 32 arc seconds. Okay, this is some random some position on the sky. It will be in the northern hemisphere above the equator, 2 degrees above the equator, quite close to the equator actually. Okay. So, this is one of the coordinates, and this is essentially the altitude. This is an altitude alt azimuthal coordinate system. So, this is the altitude. Okay. Altitude. We have now we need a second coordinate to specify the position of a point on the sky on the sphere. So, the second coordinate is as follows: you take this point over here which you wish to label, and you project this point down to the equatorial plane. Okay. So, you project this point down to the equatorial plane, and then you measure the angle that it makes, the projection makes, with respect to the spring equinox. So, you essentially what you do is you put the equatorial plane, you divide it up into angles, and you see where the 0 corresponds to the spring equinox. The spring equinox corresponds to 0, and then you see what degree, what angle the point that you wish to make when you project it on the equator, what angle it makes with the line joining here to the spring equinox, the center to the spring equinox. So, this is like the longitude. Okay. It is the angle on the equatorial plane that this projection makes. I hope it is clear, and this is called the right ascension, RA. Okay. So, the declination here is this angle, and the RA is this angle in the equatorial plane. So, if you give the RA and dec, you have identified this point. Okay. And the right ascension is measured in a slightly different unit, it is measured in hours. So, the whole equatorial plane is divided into 24 hours. Okay. It is somewhat convenient because if you stand on the earth's surface and look at the sky, the whole sky will go around in 24 hours. Okay. And this, so the whole thing goes around you in 24 hours, which is why it has been divided into hours, and these hours have been divided into minutes and seconds again. Okay. And 0 corresponds to the position of the spring equinox. So, if you have RA and declination coordinate system, say specified in the year 2000, then it will be the spring equinox of the year 2000. The spring equinox, as I have told you, the position changes with time. So, you have to specify the year in which whose spring equinox you are referring to. Okay. And so, for example, 14 hours. So, if I say 14, 25, 16, it essentially means 14 hours, 25 minutes and 16 seconds of RA. Okay. So, these are in hours, minutes and second. So, these are the coordinates that we use on the celestial sphere or on the sky. Okay. So, now let us see what we for example, let me ask you a question. Yeah, I will finish in a few minutes. I will finish in a few minutes time. So, let me ask you just one question. On 22nd or 23rd March, what will be the RA and declination of the sun? It will be 0. Why? Because on that day, that is the spring equinox, and on that day the sun cuts the equator, and that is also the 0 of the RA. So, on that day the sun is at Ra and declination of 0 approximately. Okay. In the year 2000 it is going to be, it would have been exactly 0. Now, let me ask you another question. What is the Ra of the sun, let us say 3 months after that or 10 days after that? Right. Right. So, the sun goes around this whole thing in 365 days, or you may say it does 360 degrees in 365 days. So, it does approximately 1 degree in a day. Okay. So, from there you can calculate after whatever 10 days or 20 days what the Ra of the sun is going to be. Okay. And so, that is going to be the Ra which you will have at transit at. So, there is a concept of transit. So, at any time the Ra that is exactly overhead, that by transit we refer to the Ra and declination of the Ra in particular of the point that is exactly overhead. Okay. So, at 12 noon the sun is exactly overhead approximately. So, on this at spring equinox the 0 0 Ra 0 dec transits at 12 noon, and after some time it will have be some other it will transit at some other Ra and dec will transit at 12 noon, the position of the sun. Okay. So, these are things which one has to actually do to get a feeling for. So, I will give you a brief exercise. Please, this tells you the Ra and declination of 2 of the constellations that we have discussed. These are the Orion constellation and the Ursa Major or the Great Bear or the Saptarshi Mandal constellation. Okay. And the Orion has a right ascension of 5 hours and a declination of 5 degrees. It is quite close to the equator, equatorial plane, whereas the Ursa Major has a right ascension of 11 hours and a declination of 50 degrees. Okay. So, you have to locate these on the sky. Okay. It is quite not very difficult. So, you can if you know the time that you are looking at, you can from the fact that the sun that 00 transits, that the Ra 0 transits at on March 22nd March, you know the date now. So, you can calculate what will be the what will transit at noon, and then you can calculate what you expect to transit for the time of your observation. So, I suggest that you go out tonight and identify these and then relate them to the Ra and declination values given over here. Okay. So, let us stop here for today and we shall continue tomorrow.